Happy Friday, everybody. Today's lesson is learning about L'Hopital's rule. We're going back to limits, and you're going to say, what? Why are we going back to limits? Well, we didn't learn L'Hopital's rule because we didn't know derivatives, and you have to know derivatives to do L'Hopital's rule. So here's what the rule looks like. It says if I take the limit as x goes to c of f of x over g of x, it's the same as taking the limit as x, oh, that's not 0, that should be c, x goes to c of f prime of x over g prime of x. That's what the rule says. Now, the only time you're going to use this, when are you going to use it, this is key. If you take the derivative here and it's pretty and nice, life's good, move on. Or if you get 0 over 10, it's 0, go on. If you get 10 over 0, it doesn't exist, go on. But what happens is you use L'Hopital's rule when you get 0 over 0, the indeterminate form. Okay. Now there's some other forms that we haven't talked about, infinity over infinity, negative infinity, or positive infinity. We haven't got to those yet, and we're not going to today. We're only worried about 0 over 0 today. And what L'Hopital's rule does is lets you get the limit without having to do all of the algebraic transformations. For example, this one, when you first thing you always do, always check if 0 over 0, always. Okay, so I plug in 5 and I get 0 over 0. Well, before L'Hopital's rule, we would have factored at x minus 5, x plus 5 over x minus 5. They cross out, you plug in your 5, and you get 10. What L'Hopital's rule tells us is I can go ahead and take the derivative of the top, so I'm going to have the limit, x is still going to 5, and you take the derivative and have 2x over 1, and now you plug in your 5 and you get 10. The answers are the same. This is just easier. You don't have to remember how to factor. Okay? The rest of these examples, I'm not sure why they put them in here except to remind you to check. When you plug in 5, you get the sine of 5 minus the sine of pi over 3 over 5 minus pi over 3. Well, the sine of 5 doesn't exist, so this is a DNE. No point in that. Okay? Here you plug in 5, you get the square root of 5 minus 2 over 5 minus 1, which is 1. 4 is 1. That's a number, so that's okay. You plug 2 in here, and you get what? 4 minus 10 minus 6 over 1. That's okay. So I'm not sure why those examples were on here, but we like to practice. All right, so here's some examples where it does make sense. When you plug in 0, you get e to the 0 minus 1 over 0. Well, e to the 0 is 1. You get 1 minus 1 is 0 over 0. So now you take the derivative. This is why we had to wait until now to teach this, because you just currently learned how to find the derivative of e to the 2x. So the derivative of the top is e to the 2x times 2 minus 1 over the derivative of the bottom is 1. Remember, you're still taking the limit. X is still going to 0. This is 1, so you get 2 minus 1 is 1. 1 over 1 is 1. And I have an answer. Okay? You plug in negative 1. You get 2 minus 2 over negative 1 plus 1. You get 0 over 0. Now, could you factor it? Probably. But it's easier to go ahead and do L'Hopital. And you get 4x over 1. You plug in negative 1, and you get negative 4. Peachy keen, man. Same here. This one, if I plug in 0, you get the square root of 1 minus 1 over 0. That's 0 over 0. That one we had to rationalize the numerator by multiplying by the conjugate. Well, let's not. Let's do L'Hopital. You get 1/2 times x plus 1 to the negative 1/2 over 1, and you plug in 0, Well, the square root of 1 is 1 times a half, gives you a half. Fun. Same here. What happened? You get 0 over 0. Take the derivative. 1 over 1/2 x to the negative 1/2. So what do you get? Well, let's see, now I have to do some math. There's 1 over 2 to the square root of x, which is the same as 2 square roots of x. That's 3, that's 6. Booyah, done. Okay, that's all there is to L'Hopital's rule. Enjoy your day. Keep on practicing. Next week, we'll go on and learn how to take the derivatives of inverse functions, and that's when life gets a little tricky. Have a good weekend.